Hello, and welcome to 9.5, Addition, Subtraction, and Complex Fractions. So before we talked about multiplying and dividing our fractions, but now we're moving on to adding and subtracting, which may seem like it should be easier, but it actually complicates things a little bit. If you recall, as we add and subtract our fractions, we have to make sure that our denominators are the same, okay? So let's look at these easy problems first that we should know how to do. So looking at number 1, we have the same denominator of 5, so we can add straight across. Now, remember, the only thing that changes is our numerator. We're just adding the top two numbers, so this becomes 4, and our denominator stays the same, 4 over 5. Okay, now looking at number 2, we have x and 2x as our denominators. So how would we get our denominators to be the same? Well, we're going to have to multiply this first fraction by 2 over 2. Okay, because we want to get the denominators to be the same, so we need our x to become a 2x. So that's why we multiply the top and bottom by 2. So then this becomes 10 over 2x plus 3x over 2x. So when we simplify this again, the denominator stays the same of 2x, and the numerator, could we simplify 10 and 3x? We can't combine those, so we just write that as 10 plus 3x, and that is our answer. Alright, and then our third problem here, we have the same denominator, great. So now we have to look at, we're subtracting. So when we subtract, we're not just subtracting this 3x, we're subtracting this whole 3x plus 2. So what I recommend is distributing this negative, okay? So that would be a negative 3x and a negative 2, okay? So, and that becomes a positive. So that way we don't forget to distribute to the second term. A lot of you guys will miss that, but don't forget to distribute that negative to your other terms. So we have, that will become a 4 minus 3x minus 2 all over x plus 2. Then we need to see, what can I simplify? Well, 4 and 2 we can put together. 4 and negative 2 rather. So then that becomes a negative 3x plus 2 all over x plus 2. Alrighty, so that was just a little bit of a warm-up. Now let's look at these other problems that kind of step it up a little bit. Okay, so looking at this, we have 4/5 plus 3 over x plus 2. And again, we need to have the same denominators, and we don't. So we have to think, okay, what is missing from this first denominator? Well, we're missing an x plus 2. So let's multiply the top and bottom by x plus 2 over x plus 2. And then what's missing out of this second one? Well, we're missing a 5. So we would multiply the second one by 5 over 5. Okay, so we're going to have to distribute our 4 here, and then multiply your 3 and our 5. So that would give us 4x plus 8. And then we have plus 15 all over our, if we multiply this out, would be 5x plus 10. And then let's see, can we simplify this? Well, yeah, we can combine our 8 and 15. So that would give us 4x plus 23 all over 5x plus 10. Now we could have also left this as 5 times x plus 2, but in this case it didn't really matter. So this would be our final answer. Now looking at this one, it's a little bit more tricky, where you want to see, okay, well, we have this huge polynomial and this factor of x plus 8, and we want to see what is missing out of these two. Well, our first step for some like these, when it's a big quadratic, is let's see if this can factor. So what two numbers would multiply to be 32 and add to be 12? Well, that is x plus 8 and x plus 4. So now looking at this, okay, what are we missing from our first term and our second term? Okay, well, in our first term we have an x plus 8 and an x plus 4, but in our second fraction we just have an x plus 8. So that means the only thing that we're missing is our x plus 4. So we multiply that to the top and bottom of our second fraction. We don't have to do anything with our first fraction. Okay? So we have our x squared plus x plus 3 from our first fraction. And then if I distribute out this 3x here, that would give us a positive 3x squared and a positive 12x. And that is all over our x plus 8 and x plus 4. Okay, so then now we have to see, well, what can I simplify? Well, we have an x squared here and an x squared there, and we have a x and an x. So let's combine those. So we have a 1x squared, a 3x squared, so that's a 4x squared. 1x and 12x, that's a plus 13x, and then we have our plus 3, and that's all over x plus 8 times x plus 4. Okay, and then we can say, well, can I simplify this even more? And actually the top does factor using the Batman method. You could factor that to 4x plus 1 and an x plus 3. But in this situation, it doesn't really help us out. There's nothing that we can cancel. So if you saw that you could factor it and factored it all out, you could leave it like this as well. So either way is fine. So let's move down, looking at number 6. Okay, so we have 7 over 6 times x minus 2 minus x plus 3 all over x 6x. So just like we've been doing before, we're saying what are we missing from this term that would give us our 6x, okay? Well, at this point, we don't have x being multiplied by itself, okay? So that means we're going to have to multiply the left side, top and bottom, by x. And you have to think, okay, what are we missing from the right side? Well, we're missing this whole factor of x minus 2. Okay, so let's multiply this whole thing out, and be careful here because we have a negative. Okay, so this on the numerator on the top, we would have 7x, and we have a minus, and I'm just going to put parentheses around what we multiply this out to. This becomes x squared plus x minus 6, and that's all over, we have 6x times x minus 2. Okay, so then now let's distribute. If you already distributed this negative in your previous step, that's totally fine. I'm just doing this step by step so we don't lose track of what's happening. So we have 7x minus x squared minus x plus 6 all over 6x times x minus 2. And then we can combine our like terms. So we have negative x squared, and that would be a positive 6x plus 6 all over 6x times x minus 2. And at this point, we have to look at, okay, well, can I simplify the top at all? And that doesn't factor, so then this would be our final answer. And then looking at number 7, okay, so since we have just a single factor of x and then we have a quadratic here, let's see if we can simplify our quadratic at all. Well, can this factor which numbers multiply to be 6 and add to be 5? Well, that's x plus 2 and x plus 3. So then looking at our first factor here, we have to see, well, what are we missing? We're missing our x plus 3, so we have to multiply the denominator and the numerator by x plus 3. And because this is also a factor, make sure you put parentheses around our fraction here, the top and bottom, just so you remember to FOIL. Okay, so then across the top we'll have, once we FOIL this, that gives us x squared plus 4x plus 3. And then look, we have a minus sign here, so we're going to have to distribute distribute to both. So that gives us a negative 7x minus 13 all over x plus 3 times x plus 2. And let's simplify what we have. We only have 1x squared. We have a 4x and a 7x. And then we have a 3 and a negative 13. So that gives us x squared and a negative 3x and a positive 10 all over x plus 3 times x plus 2. Okay, so then from this step we have to see, well, can we simplify the top? Do any numbers multiply to be positive 10 and add to be negative 3? Well, yes, actually. It can be simplified to x plus 2 and x minus 5. And we still have our x plus 3 and x plus 2 on the bottom. And look, we have an x plus 2 on the top and bottom, so that means we can cancel it. So then we're left with x minus 5 over x plus 3 as our final answer. Okay, so every time you need to check to make sure if you can simplify it, then you can. Okay, then you do. Alrighty, so let's turn the page over. And this one, I'm going to help you set it up, but then I want you to try it on your own, okay? So, looking at all three of our denominators, remember, because we're adding and actually subtracting these fractions, we need to see what are we missing. So in this first factor, we're missing a 2x minus 3 and an x. So that means in this factor, we're going to have to multiply this by an x and a 2x minus 3. Let's multiply it to the top as well. X and 2x minus 3. What are we missing in the middle factor? Well, we're missing our x plus 1 and our x. So we're going to have to multiply top and bottom by x and x plus 1 and x plus 1. And then what are we missing out of our last factor, or last fraction? Our x plus 1 and our 2x minus 3. Okay, so after looking at all those, make sure you don't forget this minus sign and you distribute out everything that you need to. And I recommend foiling this first before you distribute your 4 and your x. Okay, so I want you to hit pause and try that out. Alrighty, so your final answer should be 8x cubed minus 15x squared plus 9x plus 12 all over x times x plus 1 times 2x minus 3. So if you did not get that, let's look back and see what we did. So my first step was to simplify what I am multiplying each numerator by. So the first numerators we multiplied actually by 2x squared minus 3x. The second one is actually x squared plus x when you distribute your x. And then the last one was 2x squared minus x minus 3. And then I just had to make sure that I distributed properly, so I showed that here. And then you have to combine your like terms. Okay, so once you do that, it ends up being this line. Okay, so check carefully your work. Okay, if you have any questions, you can ask in class. Now, this last part, complex fractions. So complex fraction is a fraction that contains a fraction in its numerator and or denominator. Okay, so don't be frightened by this. The only thing that you need to know when using complex fractions, or remember, is you just multiply by your reciprocal. Okay, it's no different from having a fraction dividing by another fraction. Okay, that's what we talked about in 9.4 in our last video. So this is just like that. Okay, so in order to learn about this, I need you to stop this video and start looking at part 2 of our video to finish up 9.5.